Hello. In this first video segment, I will go over the basics of oscilloscopes. Essentially the y-axis, the x-axis, and the triggering. So on the screen right now, we have a signal from the output of an Arduino that it's pulse width modulated. So it has some time high and it has some time low. And maybe we want to measure that. But first of all, on the left-hand side, you will see some numbers indicating the voltage for every division on the oscilloscope. So this would represent 2 volts, 4 volts, 6 volts, 8 volts. Down at the bottom, this little window here is very important because it tells you how many volts per division that you have. And you can change that by turning this knob clockwise or counterclockwise. So if I turn it counterclockwise, I'm getting more volts per division, okay? And it goes in steps of 1, 2, and 5. And so you typically will want it to be from minimum to maximum, maybe 2 to 3 divisions. So we have it about 2.5 here, so that's fine. So that section, so this represents the number of volts per vertical division. And this represents up here the time per division. So right now I have the scope set to 1 millisecond per division. So if you look at these vertical lines, the amount of time from here to here is 1 millisecond. So I can see from that my signal, starting at this point and moving along to this point here, my signal has a period of about 2 milliseconds because it's 2 divisions. And going back to the volts per division, I can see that my signal has a voltage level of about, well, this would be 2 volts, 4 volts, halfway would be 5, so just under 5 volts, which makes sense for a TTL level. Okay, so that's the volts per the division down here and the time per division. So these are two things that you have to look at and possibly change every once in a while. So to change the time per division, you're going to adjust this dial clockwise or counterclockwise. So I'm going to go counterclockwise. And actually right now I have it set on the variable or fine divisions. If I press the button, I get increments that are in 1, 2, and 5. So we're at 500 microseconds, 200 microseconds, and if I go counterclockwise, the period is becoming higher. So if you look at the time per division, that's 10 milliseconds per division, and we're getting, quite a number of cycles on the screen. Too many to actually interpret correctly. So this is maybe too short, and the other one was too long, but this is appropriate. You want to have between maybe 3 and 7 cycles on the screen. Now, the third thing that you need to adjust every once in a while is the triggering, especially for signals that repeat. So that's called trigger level, and most of that happens over in this area here. If you want to set the trigger level to 50%, just press on the button, and that brings that trigger level to the 50% point. And that's generally a good place to set the trigger level to. And you'll notice that right now the trigger level is right in the center. Okay, and we can change that. We can change the level, the position, and even the edge that it triggers on. So for example, if you do want to make some trigger adjustments, you would click the trigger button. And let's say, for example, I want the edge to be, right now it's going from a low level to a high level. So that's called a rising edge. And if I switch this, it's triggering on a falling edge. So I can trigger on a rising or falling. I can change the trigger level. Many things that you can do with that trigger menu. And if you want to exit the trigger menu or any other menu, you can just come down to here and click on trigger. In this video, we'll use some of the different measuring tools available on this scope. So to do that, you start off by going to this button and pressing measure. and it brings up this tool. Now the first thing to notice here is measuring place. Measuring place indicates where near this bottom area the measurement will be placed. So this might be measurement 1, over here 2, over here 3, and so on. There are 6 different measuring places and 6 different measurements that we can make. So for this waveform, we're going to measure the frequency, the period, the high time, and the duty cycle. So that's going to be 4 different measurements. And we're all going to be on channel 1. So I'm going to start off by using measurement place 1 and the type of measurement. And you have basic measurements, vertical, and horizontal. Okay, so these are the different types, and there are many different types. So the first one, as I said, is that I want to measure the period of the signal. So I do that, and down here is the period of the signal. So 2.04 milliseconds. Makes sense because we're at 1 millisecond per division, and the period is going from here, falling edge here, to falling edge here, and that's about just a bit over 2 milliseconds. So we have that one measurement. The next one we want to do is the frequency. So place 2, frequency, we select that, and now we have the frequency, which is about 500 hertz. The third measurement is we wanted to measure the duty cycle, the positive duty cycle. So that's a measurement that is horizontal. So positive duty cycle right here, it's placed in the 3rd position, and it's showing me that it's about 22%, and I can actually change it, and it updates that information as I'm making the change. And the 4th one we wanted to include was the positive time. So duty cycle, that would be the positive width, which is right here. So you'll notice that you don't actually see it here. You have to either hit back or menu so that you're taking away this part of the menu. And now you have all of the measurements. So the period, the frequency, the duty cycle, and the pulse width for the positive time high. So it's positive pulse width. So it's showing 520. So if I look at this here, from here to here is 1 millisecond. And the time high is just over just over half of that, which makes sense for our measurement. Okay, so those are some of the measurements that you can make.